In this section, we will apply all the tools we developed to study a function and graph it at the end. Okay, study of, okay, so graph of function, let's say graph of a function. So this is the final result of what we will do. So we'll do, we will we will identify the steps of studying function through the following example. So we will be interested in studying the function fx equal 2x2 over x2 minus 1. So the first thing we need to know is where the function is defined. Okay. So first the domain. It's not clear. Let's change the color here. What color can we use here? The red one or the green, maybe green. So the domain first. As usual, always pay attention to the domain of the function. So clearly here we need to avoid -1 and 1. Okay, so here is the answer. d of f is minus infinity minus 1 union minus 1 1 union 1 plus infinity. Great. Is there symmetry? Yes, let's pay attention now to the symmetry for the first time. Symmetry. About symmetry, I think there is only one m for symmetry. So let's write here symmetry. So here, yes, my function is symmetric. Okay, so I can, for any x in the domain minus the opposite is inside the domain, and I can compare the two values. Let's compare. F minus x, it's 2 times minus x squared over minus x squared minus 1, which gives me 2x2 over x2 minus 1, which is fx. And this is true for any x in the domain. Okay, for any x in the domain. Then, so f is an even function. It means I can limit myself to study my function from 0 to plus infinity, for example, then deduce the other part of the graph. Once I graph the half of that, the other part will be obtained by symmetry with respect of the y-axis. Okay, so we will see if we will limit also the number of limits, which is good also. Okay, so let's do things like that. We can the derivative, compute the derivative, so that we study the monotony. Okay, so let's do things like that in this order. Naturally, we need them, so we will each time we will deal with situation. So for the monotony, we need to compute the derivative. Okay, so we have the derivative of fraction. Okay, so 2 is a factor, I can put it outside, so I need numerator 2x, x2 minus 1, okay, minus x2, derivative 2x, denominator over x2 minus 1 square. So I see I have 2x, I see that I have 2x here, 2x here, so I can put it as common factor, so I have 4x here, and then x2 minus x2 simplify, so only minus 1 is remained, so we'll have minus 4x over x2 minus 1 square times, and x2 is simplified, we said. Yes, that's all. Okay, great. So this is my derivative. It's clear. It's easy to, its sign is easy to study. So the monotony, we can do it here. Small table. let's do it, study our function everywhere so that we develop our abilities more. So we said we have to avoid -1, it's not defined, and 1. My function is not defined, okay? Then I need to study the sign. It's clear here, it's easy. So the sign of f prime of x is easy, because for x positive, I will have -4 minus x will be negative. So 0 appears here, is the only critical point. The denominator here is positive, so f prime equals 0 here. It's positive when x is positive, -4x is negative, so my function is decreasing, and here positive. So my function is increasing like that. So about fx now. Okay, so here the sign of, and here the monotony. We put the information of monotony of f. Okay, so here it is. So I have all, yes, I put all here. It is decreasing. I put those arrows to say it's increasing and decreasing. Okay, now let's we need now to fill the information at these limit points, at 1 plus infinity, -1 from the right left, and at minus infinity. So we need to fill those informations. Okay, so those are limit behaviors, so we can do that. And yes, and then we will try to start to graphing the function and see if we can do it or not. Okay, so here it is. Yes, what is my next? Yes, I need my formula. Here is my fx, so it's 2x2. You see here it is fx, so f0 is 0. Okay, now the limit behaviors, so let's do them here. We can add them here. Limit behaviors. Okay, so we will need which behavior? So we will need limit of 2x2 over x2 minus 1 as x approaches plus or minus infinity. But here fraction, we said we put the higher degree as factor, so we have x2 2 over here x2 1 minus 1 over x2. Then simplify, we can simplify by those terms, and then use the fact that it's, yes, it is reduced to that, and use the fact that limit of 1 over x2 is 0, so the limit is 2. So we will have here limit behavior of 2 and 2 here also. Okay, I think you need to put it in black or red, maybe not this color. Okay, so red, let's choose the red point. Okay, so we have 2 and we have 2 here, we have 0 here. Now let's see what is yes, what is the limit at limit my function as x approaches -1. Okay, so it will be limit x2, so I factor the denominator and see what can I get. So here, so if you substitute -1 for at x, you will get numerator 2. Okay, 2, so it's good, it's a positive, strictly positive number. Here you will get here at the denominator we will get -2, so it is behaving like this one, like 2 times -1 square. So here you will have -1 -1, so you will have -2, so something positive. But here then you will have a 0. But so here you have, so you will have something minus, yeah, -2, no, -1 over 0. But then you cannot conclude because you need to decide whether it's a 0 plus or 0 minus. So that's why you need to specify here that you are taking the limit to the left. Then you will need to compute the limit to the right separately so that you can conclude about the behavior. Okay, so the only thing that changes is the sign, but it changes everything. So here you will have by the left, so this one you will approach with x less than minus 1, x plus 1 will be less than 0, so it will be 0 minus. 0 minus with minus will give you plus infinity. Okay, so here is, yes. So this is just guessing. We are trying to understand how things are working here. Okay, and similar result this time we will get minus infinity. And yes, you can see it. Yes, it works. Indeed, we have these behaviors. Okay, so you will have here plus infinity, here minus infinity, here minus infinity, and here plus infinity. So there is similarity with this limits. Okay, great. Now the other, when you try to graph, we said we need more information, so concavity. So let's introduce concavity now, study the concavity, then graph our function. Maybe I will add it from here. Sorry, I will add it here, the concavity, instead here, so that we can graph it, put the graph there. Yes, so concavity, okay, concavity here. So we need to compute then the second, we said, yes, the second derivative. So f second of x. So to save time, I give you the formula. We can find it for x2 minus 1 times 3x2 plus 1 over x2 minus 1 power 4. Okay, so if you look at the here, the sign, this quantity is positive. Okay, this one is positive, power 4. So the sign will depend on the sign of x2. So sign of f second is equal to the sign of x2 minus 1, which is easy to see because second degree, we know that it's outside the roots of second. Sign of f second will be here, or let's put it, yes, it's better to do things well here. So if you put minus 1 here and 1, if you do your study of sign, okay, separately x minus 1, x plus 1 as we did previously, positive, negative, negative, positive, positive, negative, then x2 minus 1 will be plus, negative, and plus. Okay, so we can say then sign of f second, we said plus concavity, so concavity we can say here concave, convex, sorry. Okay, so concavity of f, concavity. So here f second is positive. Okay, sign is positive. So we will be have convex function. Here it will be a convex function, and here concave. Okay. Okay, now we can graph our function. Okay, so let's start doing the graph. Of course, here we can say we have vertical asymptotes, we have an horizontal asymptote 2, y equal 2, etc., etc. So we don't rewrite everything, but you can. So I need the concavity. I need to know, okay? So maybe it's better to write it here. Here, so here we said convex, convex. Here up to here, convex. And here, concave. So that I have everything in front of me. And now I will start to graph my function. So here it is. Let's start then. Okay. X. So I have my two values that I need to eliminate, and at the same time these are a vertical asymptote. Okay, at x equal 1, x equal minus 1. Okay, 0. What else? At 0 we have 0. We have an horizontal tangent. So let's put all the things that are important in red and see them clearly. Okay, there is only one critical point. We have an horizontal tangent also. Let's put it in green. Y equal 2. So let's say here 2. Okay, it's an horizontal line. Y equal 2. So this is horizontal asymptote. Horizontal asymptote. There's two are vertical asymptotes. Vertical asymptotes. Okay. Great. Great. Now, from the table, I read that when for x less than minus 1, my curve close to 2, y equal 2, and the fx keep growing, going to plus infinity, less than minus 1, okay, and the shape is globally convex. Convex, so it is increasing. So convex, we said smiley curve, smiley shape. Now it is clear that the graph of the curve will not touch meet the asymptote because my function is not defined at minus. So here for sure we will have a behavior like that, something like that. Now here I am close to 2, but I'm not sure whether I will start above 2 or less than 2. So to see that, so we need to explore the intersection of the graph with with the asymptote. So intersection of the graph and y equal 2. So this is a problem. Sometimes you need to explore. Okay. So we need to solve the equation y equal 2x2 over x2 minus 1 equal 2. So that means 2x2 equal 2x2 minus 2, which is if you simplify we get 0 minus 2, so it's impossible. So it doesn't cross. So necessarily it will be above. Okay, so that it keeps increasing. Okay, so let's go back then and graph this part. Okay, so we will have something like that for this part. Okay, then between minus 1 and 0 my function is concave. it is close to, it takes large negative values when my x is close to -1, my fx are close to minus infinity, the y's. Then my function keep increasing with the shape that is concave, and attains these maximum local maximum values. So it will have this shape like that. Okay, here it is. And similar, yeah, and by symmetry, then I can use the symmetry. I can use the symmetry and graph my graph. Okay, here it is. So here are the steps you need to know when you want to graph a function. You need to go through all these questions naturally. They come in order. Okay, so sometimes you need to know the intersection with the axis, so you need to explore everything. Okay, thank you.